Good morning and welcome back to my channel, and today we're going to be deriving the product rule, which is something you learn in A-level maths, specifically A-level year 2 if you're doing a 2-year side-by-side maths and further maths course. So the product rule. First, what on earth is this for? So this is for a situation where you have f of x is equal to g of x times h of x. So two functions in x multiplied. So let's say you had x squared times e to the x. That's two functions. So one function here times by another function of x here. So how are we going to differentiate this? Well, first of all, we are doing this by first principles, I should say. F dash of x is going to be equal to the limit as delta tends to 0. I'm using delta because we have an h already here, and so it would be a bit confusing if I used h's as my limits. So, lim as delta tends to 0 of g x plus delta h x plus delta minus g of x h of x over delta. Nothing really new here if you've done differentiation by first principles. If you haven't, I will cover that in more detail later on. Not in this video though. So, and that is equal to the limit. What we're going to do here is a nice factoring trick where we're going to basically add 0 by adding something and then subtracting it straight away afterwards, but just so that we can factorize things. So limit as delta tends to 0 of g of x plus delta h of x plus delta minus g of x h of x plus delta plus g of x h of x plus delta. So we've minused and then we've added it. Minus g of x h of x. So the expression that I've written is completely congruent, or the same value as the expression before, because these two bits of the equation are equal in magnitude but opposite in sign. So they will cancel out and they will be equal to 0. And this will be equal to the limit, we're doing some factorizing now, as delta tends to 0 of h x plus delta times a whole bracket all over delta g of x plus delta minus g of x over delta. Now, some of you may have spotted a pattern already. It's okay if you haven't. It will become more clear later. Why have I done that? Delta tends to 0 of g of x times h of x plus delta minus h of x all over delta. Now, the next thing I'm going to do is, well, it's perfectly allowed. I'm going to use the limit here. I'm going to say that the x plus delta, as delta tends to 0, is just going to be h of x. So I'm going to put h of x on the outside because it's a constant, and so it's actually not affected in the differentiation. So h of x times the limit as delta tends to 0 of g of x plus delta minus g of x all over delta plus g of x times the limit as delta tends to 0 of h of x plus delta minus h of x over delta. Now, the thing I was wanting you to spot was that this limit here and this limit here are just the definitions of g dash of x and h dash of x. So what we have is hx times g dash of x plus g of x times h dash of x. And that is what you will learn if you learn the product rule. You won't learn this derivation, but you will learn this rule here. So I'm going to put a little square because it's a nice proof, and I will see you all next time.